Good morning, dear students. Today we will discuss graphic aids. In last presentation, we discussed descriptive analysis, like how would we go with mean, median, mode, and things like that. And we started with tabulation form as well. Tables can be generated in so many forms, right? This is one step ahead of tabulation. Though we'll be discussing tabulation as well. Like when it comes to graphic aids, tables are the first step, right? Then there would be so many steps ahead. Tables basically are a graphic aid generally used for presenting numerical information, especially when such information can be arranged in rows and columns. It points out significant features without getting bogged down in details, right? This is what a table is. We can have a look at this example. This is how a table looks like. You can, for example, there's a question: would you say you are enjoying your work more, less, or same as you were 5 years ago? How can you tabulate it like this? You can provide all the options in these columns, and all the possible people you have interviewed, or all the possible categories of respondent can be presented here like this. Overall, total collaboration of all the respondents, then professionals, technicians, and sales workers, how differently they have replied. You can see the percentage here, right? This is one form. In this also you will be reading, and then you will be able to analyze that how whether whether they are enjoying it or not, they are whether they are enjoying more or less, something like that. You will have to at least read this figure, then this, then this, then you will be able to analyze that yes, which portion is more and which is less, right? But in case of charts and graphs, you do not have to read everything. You will just have a look and you will come to know that yes, this is the portion which is more utilized, and this is less utilized portion, like this way. You know that when it comes to the comparison of revenues of Dell and Apple, it can easily be seen from here that revenues of Apple are less than revenues of Dell. This way you can see it just by having a look at it, right? You do not have to read any figure if you just want to see which one is ahead of which, right? But in case of tables, you just have to go with the data. You have to read all the data, then only you will realize that yes, which portion is less and which is more, right? No doubt this is much better than randomly available data. This is this also requires a lot of effort to reach to this step, but this particular step, graphic aids, is one step ahead of tabulation. Graphic aids basically is a picture or diagram used to clarify a complex point or to emphasize a message. Examples are charts. These are examples of graphic aids, then diagrams and maps. Charts or graphs. It's a graphic aid used to translate numerical information into visual form so that relationships may be easily understood. This can have like pie charts, line graphs, and bar charts, vertical as well as horizontal. We'll see both of them in upcoming slides. Pie charts. A graphic aid that shows the composition of some total quantity at a particular time. Each angle or slice is proportional to its percentage of the whole. Like this you can see, like pizza slices. You can see the percentages here in a pie chart. Example, this way. You can check the sales of a company over years this way, right? Or better this way. Like, for example, how much time off you want. If you ask employees, then they might reply this way, and you can form it in the form of a pie chart. Like 4% people said they want 6 week vacation, 7% people said they want 5 weeks time off, 18% said they want 4 weeks time, 20%, 25% people said they want 3 weeks time, 34% people said they want 2 weeks time, and 13 people said they want 1 week time. Just by having a look at this graph, you can always say that this is the maximum. This is the graph. This is the pie, you can say, which consists of maximum people, maximum respondents. Right. So this is the advantage in case of graphic aids. Then line graph. Graphic aids showing the relationship of one variable to another. The dependent variable is generally shown on the vertical axis and the independent variable on the horizontal axis, like this. Vertical axis would be common, and then variable would be, independent variable would be shown on horizontal axis. This is a kind of example of line chart. This way you can present. For example, if you want to compare two companies' expenses or their revenues, you can always compare them in this way. And this line shows that Airtel is ahead of BSNL from somewhere in mid of 2004 to 5. Right, this shows it very beautifully without any words. You can just have a look and understand everything. It is much better than a tabular form. Of course, it would be generated after once you have generated a table. But yes, how would you show this line graph is also another thing. How this is a normal line graph, right? If you shrink it like this, it would show you another picture. And if you expand it like this, it would show you another picture. You might see these two, this one and this graph in another picture now. So this is also very important. How would you picture the graph? Then bar graph, a graphic aid that shows changes in variable at discrete intervals, like this. You will be showing things with the help of bar graphs, like we just mentioned in the case of Apple and Dell. Like the you can say the performance of three companies or three areas in first, second, third, and fourth quarter of the year, right? And in this you can actually see that everywhere this green color is having the maximum marks, maximum points, except third quarter. Here this east is performing better, right? So graphs are much better than tables, much better than the analysis. But yes, it depends what kind of the data is available, what kind of the study you are going to do. On that basis you will decide whether you will be going for graphical aids or the analysis. Are when you talk about descriptive analysis and tables, that is another thing. But when you talk about analysis like regression, correlation, factor analysis, these are different analysis. These are not comparable with graphs or say graphical aids. Graphical aids we talk about till descriptive analysis only. This was example of vertical graphs. Vertical graphs are being presented here, and this is an example of horizontal bar graphs. For example, how did you find your last job? These might be the answers available to you, and 1.5% people said temporary agency, 9.6% said with the help of placement firm, 15% said online recruitment site, 18.3% said print ad, and 55.2% people said networking. And even if you don't look at these figures, you can easily see that this red bar is having the highest value, and this is networking. And along with this bar graph, you can actually show values like this also, like 643 people in actual said networking. This is about people, and here we have shown the percentages. You can even alternate these two things, so that's okay. There are softwares, all the softwares would do the same, these jobs for you very brilliantly. SPSS, like we have mentioned in the case of descriptive analysis as well, This is the most used software and it is very easy to use. It's very user friendly. Then SAS is there. SAS is also being used by maximum users these days, for especially in case of descriptive analysis. Then Systat is there. This is also being used by maximum users in case of charts, web charts, graphs, lines, and everything. Microsoft Excel is also being used for everything. This is little less user friendly than SPSS and the other softwares, but this is the best one. If you can if you start using Microsoft Excel once, then you can master it. Web surveyor is also one of the options. This provides you all the options in one, you know, everything, all kind of charts, graphs, tables, and within, you know, seconds. And you do not even have to transfer the data from one place to another one. You can actually directly enter the data in web surveyor. You can collect data through web surveyor and then analyze through web surveyor only. That can also be done. Then there are some other programs, for example, box and whisker plots, interquartile range, that is used basically for mid spread, and outliers. Outliers are actually checked after the graphs and everything is done. Once you have gone with descriptive analysis, then your graphs, charts, all the graphic aids, then you come to this particular stage where you will be checking your data for normality and whether your data is normal or not, whether your data is actually right for the further analysis or not. So that is why we are using these here: box and whisker plots, interquartile range, and outlier. Box and whisker plot are the rectangular plot encompasses 50% of data values, like this rectangular plot, right? Then a center line marking median and going through width of box. This center line marking the median and going through this width of the box, right? The edges of the box are called hinges. These edges are called as hinges. And the whiskers that extend from the right and left hinges to the largest and smaller values. This is this with whiskers, right? So, and this also tells you somewhere about the normality of the data, whether your data is normal or not. Then only you can proceed with other data which are actually based on parametric, or you can say metric data, or you can say which are actually dependent on this, whether the data is normal or not. Then interquartile range. This range is basically calculated to check how your mean median is spread throughout the data and what kind of the data you have, again to check the normality. Then outliers, these can be basically checked through histograms as well. Histograms are generally made to check whether there is some data, some value which is lying outside the histogram. Then you will be either checking the data, either checking the value, whether it is mistakenly put in, you know, some other variables or something like that. For example, that is the best example here. Like you might have mistakenly entered date of birth you know, in 1873 rather than 1973. These are all the functions, these are all the tools, statistical operations you can use. Paste function basically is provided in MS Excel, and you can go through this. You will find all the statistical tool analysis over there. And if you check it very carefully, statistical analysis is always available there. And this is the most widely used you can say program software by people who know what MS Excel can do, who know the basics of MS Excel. This way you will be getting all the details related to one data. There are some just few entries and you will be getting everything: standard error, median, mode, standard deviation, standard variance, right? Kurtosis, skewness, range, minimum, maximum value, sum, count, and confidence level. Everything you will be able to get within just you know, few clicks. Just with just one click you can go with the analysis. You can be done with the analysis, and this requires very less time after you have collected the data. Data analysis requires or say takes the minimum time in the whole research process. The thing is, how do you interpret this data now? Or computer graphics, computer mapping can be done this way. Computer generated graphics and charts may be created inexpensively and quickly with easy to use software programs like PowerPoint as well. These are both user friendly and versatile. This way you can actually create anything, like all the computer mapping programs, all computer graphics. You can take 10 companies and you might be checking their performance like this with the help of line graphs. This is line graph is most widely used when it comes to comparison of companies, right? So this is the best used, you can say, technique, and these are really helpful in analyzing anything. That's it. Let us discuss some true false now. Number one, the purpose of a table in a research report is to summarize and communicate the meaning of the data to the reader. Is it? Yes. So it is true. Even with today's advances in technology, computing power is still a barrier to to complete a research project. Is it? Yes, computing power is still a barrier because no, computing power is not a barrier, so that means it is a false. Third is box and whisker plots provide graphic representations of central tendencies, percentiles, variabilities, and the shape of frequency distributions. Is it? We have just discussed in the last, and it is, yes, it provides you the graphic representation of central tendencies. We discussed it with the help of median, right? So it is true. An extreme value that lies far outside of the normal range of most of the data in a distribution, either as a very high score or as a very low score, is called an outlier. Is it? An extreme value that lies far outside of the normal range of most of the data in a distribution is called an outlier. Yes, this is correct. And I shared the example of date of birth here. Like, for example, somebody's date of birth is 1973 and you wrongly entered it as 1873. So that would be counted as an outlier. While making histograms, you'll be checking the values, whether they are available, they are all in the histograms or somewhere lying outside. That outside value would be considered as an outlier, right? So this is right, true. Fifth is, in the business research, the process of interpretation should explain the meaning of the data in the research study to reader of the research report. Is it? In business research, the process of interpretation should actually explain all the meaning of all the available data in the report, in the research study, and all kind of variables you have used in the study. So that is true. Last is, data are sometimes merely reported and not interpreted. Yes, it happens. In most of the research studies, you will see people just report the data and do not interpret them. Sometimes data is like that. For example, in case of graphs, charts, you do not have to explain them. You do not have to make efforts while explaining them. A chart or graph itself explain it itself, right? So that is also one of the reason that why don't they explain the data or interpret the data. But yes, in most of the research studies it happens that they are merely reported and not interpreted. It is true. Some self-assessment questions. Number one, list down all the graphic aids which can help data analysis. What are the kind of graphic aids you can use? Number one, table, right? Table is the first graphic aid you can use. Then with the help of table, you can generate charts and graphs, right? Line chart, pie chart, bar chart, horizontally as well as vertically. Then you can mention histograms, your box and whisker plots, those are also under this, right? So these are all the graphic aids you generally use in case of data analysis. You can just mention, you can just list down all the graphic aids and then explain them with the, at least within 1 or 2 lines. Then second is explain line chart with example. You'll explain what line chart is, and you can take one example. Like we discussed an example of Apple and Dell, like about their revenues, right? So you can discuss one example with line chart. Third is list different computer software products designed for descriptive statistical analysis. There are so many softwares available. Basically SPSS, you have SAS, SAS, you have Minitab, you have Systat, you have MS Excel, Web Surveyor. So many programs are available, softwares are available. You can mention any of them, and it would look good if you list them and then provide little about them, like at least you explain them in 2-3 lines each. Last is explain the components of a Bosc and Whisker plot. We have mentioned, we have learned Bosc and Whisker plot in the last slide, right? And you can mention all the pointers with the help of diagram as well, like we have discussed it in the PPT. Box and whisker plots provide graphic representation of central tendencies. Like we just had a question in our true false like this. Provide graphic representation of central tendencies, percentiles, variabilities, and the shapes of frequency distributions. You mention the definition, and then with the help of graph, with the help of a diagram, you mention, you explain all the components of box and whisker plot. That's it. Thank you. In our next presentation, we'll be discussing univariate analysis. Till now, we discussed editing and coding, how to make data usable. Then we discussed descriptive analysis, like how to describe the data. That's it. We were just describing the data with the help of central tendency, mean, median, mode, or with the help of your standard deviation, right? These were the things. Then we were trying to beautifully show the data with the help of graphical aids, with the help of bar graph, line graph, pie chart, histograms, right? Now, after talking about data, we will be analyzing it now. And in that, we might have, had generated hypothesis in the starting of the study. We will be talking in terms of hypothesis from hereafter, from the starting of univariate analysis. We will be discussing what kind of the data we have, whether our data is normal or non-normal. Accordingly, we'll be choosing the analysis. What kind of the variables we have, how many variables we have, how many categories we have, whether we want to check the differences between the variables, or whether we want to check whether they are related to each other or not, whether they affect each other or not. Accordingly, we will decide which kind of the analysis we are going for. When we are going to check the differences between the variables, we have got t-test, ANOVA test. If we want to check the their dependency on each other, we can go with factor analysis, we can go with correlation if we want to check whether one variable is associated with another one, or we can check one variable's effect on another one with the help of regression. So many analyses are available. We will be discussing them one by one in upcoming all the presentations now, and we will be starting with univariate analysis in our next presentation. Okay.